All right, so 7.2a and b, multiplying and dividing radicals is the first part of this. Basically, again, you can copy these notes from Google Classroom. You can press pause and copy it from here. I'm going to just kind of go through some things. Basically, what I'm saying up here is that we can take something and separate it, and that's something that is separated, and put it together as long as they share the same root. Or we can take something that's together and separate it. For instance, 5 times square root of 5 times square root of 20. That's not something you probably can do in your head, but if you multiply them together, well, we can take the square root of 100 pretty nice. Then I've got some other examples here. This breaks down into 16 and 3, but we're always trying to look for something we can take the square root of and something we can't. What we can, we take out. What we can't, we keep under. Right here, cube root of 27 we can do. Cube root of x is 6 we can do. We're good to go. But in this problem, I can't take the cube root of either of these evenly. So I have to find cube roots, which cube root of 27 is 3, cube root of 8 is 2. So I'm looking for 27 and 8 to go into these. 27 obviously doesn't. 8 times 4 is 32, so I can do the cube root of 8 and the cube root of 4. That equals 32. Then for 7, well, I'm looking for the highest exponent that 3 will go into that's close to 7. Well, that would be 6. So I can take the cube root of that, that's x squared. I can take cube root of that, that's 2. And the ones that I can't, just go back under the sign. Same thing with division. We can keep them separate or put them together, whatever works out better. Here, if I separate them each, I can see that I can square root both terms and it comes out nice. Here, when they're separate though, sometimes if you put them together, well, that works out nice too. So whatever's easier. And you can see an example, see how I did that as well. Let me go on here to the actual problems. Here, again, if I combine them, square root of 16, that's easy. Cube root of negative 125, again, remember that's a negative. And then I had you guys try a few again. For all of these notes, I would write down the bold ones and then try the other ones and check your answers. You can press pause at any time, of course. Okay, so now I'm going to continue looking here at the next set of problems because these are getting a little bit harder. So you've got to split those up. This is 8 and 9, but if you go 8 and 9, then I have to take the square root of 8, square root of 9, which is 3. But I can break this up into square root of 4 and square root of 2, and it just becomes so much more steps. Find the biggest one, use a calculator. Square root of 36 I can do, square root of 2 I can't, goes back under. X squared I can do, square root of x goes back under. Same thing here, I split it up again, cube root, so we're going to think 8 or 27. Oh, 8 goes into there 10 times. The 8 I can do, the 10 that I can't goes back under. Again, n3 and n2 add up to n5. That I can take, that's n. This I can't, it goes back under. 25 and 2, 5 can goes here, 2 goes back under. I can take the square root of that, perfectly good to go. Same thing on 11. 27 and 2. It's not 8 because 8 times 7 is 56, not 54. 27 and 2, cube root of that I can do, that I cannot, that I can do, that I cannot. Again, I split this into 3 and 1 because 3 is the biggest number close to 4 that 3 will go into. Okay? Looking at 12, cube root of these terms. I put it all together by just multiplying it through. 54 times 5 is 270. x2, x3 is x5. y3, y4 is y7, and now I got to split this up into something I can take cube roots of and something I can't. If I divide 8 into 270, it does not come out evenly, but if I divide 27 into 270, of course that's 10. So I get those, I can take the cube root of that I can't, goes back under. This I'm going to split up into 3 and 2 because 3 will go into 3 evenly to give me that. This it will not, goes back under. Cube root of y to the 6th and y to the 1st because 3 goes into 6 evenly. And when it doesn't, goes back under. That's it, that's my answer. And then I would want you to stop, pause it, and try 14 to see if you can get it. And in 14, you'll see, multiply those together. Again, I get to here, stuff I can cube root, and then the stuff that I can't goes back under. Okay. Then we moved on to 13. We multiply with outside, and inside with inside. That's how I got to here. This might be tough, but look at all the perfect squares. Does 4 go into it? Nope. Does 9 go into it? Nope. Does 16? Does 25? Does 36? Does 49? Yep. 49 goes into it 3 times. So I can take that square root out. The one I can't goes back under. I can take the square root of that. I can take the square root of that. And then I'm just multiplying the 6 times 7 in the end to give me 42. Then you would try 15. Press pause. Try 15. Multiply outside with outside, inside with inside. I can square root 81. X is 7th, I cannot, so I split that up into 6 and 1. Square root that to get here. The ones that I cannot, go back under. Simplify by just multiplying the 4 times the 9. Down at the bottom, Again, I can simplify this by just dividing those. If I divide those, I get -8. Well, I can take the cube root of that, nice. Divide these out to get here. I can take the square root of 4. X to the third, I got to split up to 2 and 1s because I can square root that to give me x, and the one I can't stays. Divide this in my calculator, I get 9. Well, the square root of 9 is just 3. Divide this, I get 54. I can take that and split it into 27 and 2. So I can take the cube root of 27. The 2 I can't stays. Cube root of x cubed comes out as just an x. That 3 is attached here, not to the x. And then on 20, when I divide it, I get 4th root of 256 x to the 14th because I just subtract 1 from each of these. That I can take a perfect 4th root of. I can show you in your calculator to do that. You would press 4, you'd go to math, and you type the x root button. So now it's taking the 4th root, and then you type in 256. It will tell you it's 4. I can take the 4th root of x to the 12th by power over root. The one I can't goes back under, and that's my answer. Okay. 7.2b, the next section. You can see my notes here. You're going to always simplify first. You can kind of copy through this if you need to. Okay. But then all it is, and we've kind of been doing this all year, is we can't have radicals in the denominator. So we just multiply the top and bottom by it and reduce. Okay. Right here, I'm going to simplify it first. So I get to here, I can take the square root of the top already to get x. When I get to here to get rid of it, I just times by the square root of that again to the top and bottom. Example 3, we're not going to do in regular. So you could do 4, it's just like 1. You can do 5, it's just like 2. And then again, we're not going to do 6. Okay. Down at the bottom, simplify it first. I can't divide these out, but I can divide the x's out. I can divide the y's out to at least get me here. Now I'm going to split this up. I can take the square root of x to the 6th, that's x cubed. I can take the square root of 25 to give me 5, and the one I can't stays. On the bottom, I have this now. Well, now I have to do the top and bottom right there by square root of 3y over square root of 3y. Multiply what's in with what's in. That's how I get 6y. In with in gives me square root of 9y squared. Square root of that is 3. Square root of that is y. I've got my solution right here. Next problem, simplify it. And check this out. When I simplify it, I get square root of y squared on bottom. Well, that's just y. So now all I got to do is fix the top. Square root of 15 I can't do. X to the third becomes x squared and x. I can take the square root of that out. The one I can't stays with it. And that's how I do that. Okay. Your homework for this, for 7a, is, let's see, we're not going to do that one. That one, we're not going to do, nope, that's it. So we can do 1 through at least 13, and then I think we can do 16 through 18 as well, because I think you need more examples the better you are. And then for 7.2b, we are, let's see, I think we're going to do every problem. We're not going to do 8, I take that back. We're not going to do 3, we're not going to do 9, and we're not going to do 4. We're not going to do those cube root denominators. I'm not worried about that. I don't even want to discuss it. But you can do the rest of this assignment. Have a good day.